So the third part of the essentials, or extension, sorry, is this idea of being able to get the equation with the x-intercepts and the y-intercept. And you did this a little bit. If you look back in the essentials, you remember from the graph, you could take the two x-intercepts and you could get them as the equation, and it was called here, we scroll up here, we called it the factored form of the equation, okay, such as the factored form. So that's kind of what we're doing with this. We're going to write this in factored form. And so what happens is you can write it like this. And these, this m and n, these are your x-intercepts. So I can write my equation, if I'm given the x-intercepts, I can write my equation as a onto x minus m, the first x-intercept, which is minus 1, and x minus n, which is the other x-intercept. So that gives me an equation that says this. A is multiplied by x plus 1, which is multiplied by x minus 2. Now you notice the big heading is solving for a, and the reason that is there is because we haven't used this yet. We haven't used the y-intercept. So we're going to use the y-intercept. We're going to say that that's when x is 0, we know that y is minus 2. So we're going to say minus 2 is equal to a onto 0 plus 1 times 0 minus 2. So that means minus 2 is equal to a times 1 times minus 2. So minus 2 is equal to minus 2a. 1 times minus 2 is minus 2. And we're going to divide both sides by minus 2 to give me a is equal to 1. So that means my equation now looks like this. Y is equal to x plus 1 times x minus 2, because the a is 1. And then all I have to do to get my standard form is expand that. So then I just go x times x, that's x squared. X times minus 2 is minus 2x. 1 times x is x. And 1 times minus 2 is minus 2. And so my equation becomes x squared minus x minus 2. That's my standard form. So that's how you use the x-intercepts and the y-intercept to find your equation. It's kind of a neat thing. So we'll do another example, and then I'll let you do the other ones on your own. So we'll just back this, erase this stuff. But as we're doing that, you can think, what are the x-intercepts in my next one? And actually, the x-intercepts are exactly the same. So I'm going to stop right here, because you'll notice the x-intercepts are the same. So this equation still holds true. It's still y is equal to a onto x plus 1 times x minus 2. The only difference is now we've changed the y-intercept. The y-intercept is now minus 4. So I'm going to plug in minus 4 for y and 0 for x. And that's going to give me minus 4 is equal to a times 1 times minus 2, which means minus 4 is minus 2a. And I'm going to divide both by minus 2. And that gives me 2 for a. So now a is 2. So y is equal to 2 times x plus 1 times x minus 2. All right, now we know this is x squared minus x minus 2 because we just multiplied it out in the last question. So then we just multiply that by 2 and get 2x squared minus 2x minus 4. Okay, so if the y-intercept doubled, then that's how we end up there. And then you can try the other ones on your own. They're the same kind of idea, and there's more of them here. Okay. The other thing you can be given is roots and just a point. So it doesn't have to be the y-intercept. Okay. So again, if you're given the roots, you go like this. Y equals a onto x minus 5 and x minus minus 2. Okay, because those are our two x-intercepts. So y is equal to a, x minus 5, x plus 2. And then we plug this point in. That's my x. That's my y. So I go minus 36 is equal to a times 1 minus 5 onto 1 plus 2. So minus 36 is equal to a onto minus 4 times 3. So minus 36 is equal to minus 12a, because minus 4 times 3. And then I'm going to divide by minus 12. Okay, so a becomes 3. Minus 36 divided by minus 12 is 3. So my equation is y is equal to 3 onto x minus 5, x plus 2. And if I want to expand that to get the general form, then I can. But this is actually okay. That's the equation of a quadratic function. So you can leave it like that. If we expanded it, we'd get 3 times x, that's x squared. Then x times 2, that's 2x. And then minus 5 times x is minus 5x. And minus 5 times 2 is minus 10. So we would get 3 times x squared plus 2x minus 5x is minus 3x minus 10. And then we could multiply everything by 3. So 3x squared minus 9x minus 30. That's also an equation of the quadratic. Okay. And you can practice again with these. So if you have a root, if you're given a root, if there's only one, if the root's just minus 1 in this, then what you would do is you'd say it's a double root. So you'd write it as x minus minus 1 squared. Okay? Or x minus minus 1, x minus minus 1. You know, you'd start with, so you get y equals a onto x plus 1 times x plus 1. Okay, and then you do the same thing. You plug in 1 and 2, and away you go. So that's how you solve for a. And again, there's more questions there for you to practice. So we'll leave it at that for that one. The next thing is to determine the roots and the vertex, and then I think, yes, then partial factoring after that. So let's stop it there.